Welcome to the Explainer. You know, you're about to use a secret, incredibly complex system of rules without even realizing it. In fact, you're using it this very second. It's the hidden system that governs the sounds of your language. And today, we're going to pull back the curtain and see how it works.
All right, let's jump right in with a puzzle that drives anyone learning English completely bonkers: the spelling. I mean, think about it. You see the letters EA in P and EY in key. But when we say them, we hear the exact same vowel sound. Why? What is the hidden logic there?
Well, the answer isn't in the letters you see on a page. It's all about the sounds we make. And you know, those sounds aren't just a random jumble of noises. They actually follow a hidden blueprint, a subconscious set of rules our brain uses to decide what's meaningful and what's just noise. And that blueprint, that invisible system, is exactly what we're here to explore. It is the secret engine that makes language run.
Now, to really get this, we need to know two key terms. First, there's phonetics. Think of phonetics as this giant warehouse of every possible sound a human can physically make, just the raw materials. But then you have phonology, and phonology is the architect's blueprint. It tells a specific language, like English or Japanese, which sounds to grab from that warehouse and how to organize them to actually build meaning. So, if our language is following a blueprint, what's the machine that's building everything? Well, it's an instrument that all of us carry around every single day.
And here it is, your vocal tract. Everything from your lips and your teeth to your tongue, all the way down to your vocal folds. It all kicks off with air pushed up from the lungs. And what happens to that air on its way out? That's what creates speech.
You can think of it like a musical instrument, really. By changing the shape of this space, by moving our tongue or closing our lips, we block or squeeze that airflow in really precise ways. And that's how we produce all the different sounds of our language.
Let's try it together. To make a P sound, P, do you feel how both of your lips come together to stop the air for a second? That's what we call a bilabial sound. Okay, now try a T sound, T. Feel where your tongue goes? It's touching that bumpy ridge right behind your top teeth. That's the alveolar ridge. Every single consonant is defined by where in your mouth all the action is happening.
Okay, now we are getting to the single most important idea in all of phonology. This is the fundamental unit, the very atom that all spoken words are built from.
It's called a phoneme. And put simply, a phoneme is the smallest little piece of sound that can actually change what a word means. Think of them like Lego bricks. If you swap out one brick for a different color, you've suddenly built something totally new.
But wait a minute, if we don't consciously think about them, how in the world do linguists prove that they even exist? Well, they use this really clever and actually pretty simple test.
It's called the minimal pair test. All you do is find two words that are identical in every single way, except for one sound. So take the words fat and pat. The only thing that's different is that very first sound you have a f versus a p. And here's the magic question. Does that tiny little sound swap change the meaning of the word? Oh, absolutely. Fat and pat mean two completely different things. And just like that, boom, we've proven that f and p are distinct, meaningful building blocks or phonemes in the English sound system.
But here's where it gets really interesting. It turns out that not every difference in sound actually matters when it comes to meaning. Let's look at a super subtle one, a tiny little puff of air that we make with certain sounds.
So if you hold your hand in front of your mouth and you say the word pig, you should feel that little puff of air, right? That's called aspiration. But even if you tried really hard to say it without that puff, it would still mean pig. For us English speakers, that puff of air doesn't change the meaning one bit, so it's not a phony.
But check this out, because this is amazing. That same little puff of air that's meaningless in English is absolutely critical in other languages. In Thai, if you say pa with that puff, it means forest. But if you say it without the puff, it means split. A completely different word hinges on that one tiny puff of air. That proves that for Thai speakers, aspiration is a phone.
So what this means is that every language has its own unique toolkit of these meaningful sounds, its own set of phonemes. And understanding this one idea unlocks so much about why learning a new language can be so darn tricky and why certain accents sound the way they do.
Okay, let's take a classic example for English language learners. For a native English speaker, the words grass and glass are obviously different, right? That R and L sound are clearly distinct phonemes for us.
But for many native Japanese speakers, telling those two apart is really difficult. And why is that? It's because the Japanese sound system doesn't have separate L and R phonemes. Their language actually groups them together into a single sound category. So, to learn English, they have to learn a brand new phonemic rule that just doesn't exist in their native language.
And it can get even more mind-bending. Some languages use features that English speakers barely even register. In Mandarin Chinese, the pitch of your voice, the tone, is a phoneme. The exact same syllable, ma, can mean mother, scold, horse, or hemp, all depending on whether your voice goes up, down, or stays flat. The melody itself is where the meaning is. It's incredible.
And finally, phonology reveals the subconscious shortcuts our brains are always taking to make speaking smoother. First, there's assimilation. That's when a sound changes to be more like its neighbor. It's why tempura so naturally becomes tempura. That N sound turns into an M to get ready for the P. Then there's deletion, where we drop sounds, like when he handed her his hat just becomes he handed her his hat. And sometimes, sounds even swap places. That's called metathesis, and it's why some people pronounce ask as ax. These aren't mistakes. This is your internal rulebook making things more efficient. So the next time you speak, just take a second and listen to yourself. You're not just making sounds. You are expertly conducting a complex orchestra, following a secret rulebook you never even knew you had. And that is the hidden genius that makes language possible.